lose the paper.
Rightio, welcome everyone. Do I need this? Can you hear me if I don't use that?
Yeah.
Yes? Okay, we won't use that. Even though we're calling it open
Do
mic.
I need this?
Maybe I'll just hold it. So welcome everybody. For those of you who haven't met, my name's Scott Powell. I'm the Regional Director. My pleasure to open up our 4th edition of Open Mic, hashtag long story short. So this initiative was kicked off really to unearth, if you like, some of the stories that go on in our day-to-day delivering projects and implementing strategy at the same time. So the idea is we want to have a look at the project in the background, what the issue was, what the solution we came up with and what the outcome was. And so we've got 3 brave souls who have put their hand up to share their story. They've got about 5 minutes to share their story and I'll introduce them now. So firstly we've got Hugh Kelly, who's a Senior Surveyor at Aurecon. He's going to be sharing with us some of the ideas that have come out of the Blue Mountains Route Clearance project. We've then got Josh Nelson, who's a digital specialist, telling us some stories about rail feeders and the model-based design that we've been using on those. And then lastly, we've got Jason Pereira, who is a Technical Director in Built Environment, and he is opening the bonnet on Central Station Mainworks and going to share some of the stories we've got coming out of those. So the idea is that we are looking at our strategy in action through a long story short. So without further ado, I will hand over to who's going first on my run sheet. Hugh. All of you. Now, you got one of those. Put those up. I'm going to hand that to you.
Boom. So as mentioned, I'm the first victim today, and this is my first time doing a presentation, so I'm not in the slightest bit nervous either. The Blue Mountains Route Clearance project, I believe that's the wrong slide.
That small one.
Yeah, the Blue Mountains Route Clearance project is a project that I've been involved on for about the last 6 months. It's a project for Transport for New South Wales. Do I need this? Okay. I've got 2 mics now. It's a project for Transport for New South Wales where we're going to put the new intercity fleet up through the Blue Mountains. The new fleet is a little bit wider than the current narrow electrics that operate there. Testing?
Yeah.
All right. It's wider than the existing fleet that's going up there, but don't worry, that was completely intentional. It's to provide extra comfort for long distance travelers coming from the mountains. As a result, the wider fleet, it's going to infringe a little bit on different areas of the 80 kilometres that we investigated. I'm not going to talk about all the 80 kilometres, I'm going to focus on a small 5 kilometre section known as the 10 tunnel deviation. It's just outside Lithgow. It's a World Heritage listed site, so it's a very beautiful, very picturesque area to work in. And yeah, it's been a fantastic journey so far. The client did provide us with 2 different data sets to do our analysis on. The only problem with that was that the first data set, while being in the right coordinate system, was not accurate enough for us to do our analysis. And the second data set, while being accurate enough, it wasn't in the right coordinate system. So after a brief discussion, we decided that we were just going to go out and capture the data all over again using our fantastic Aurecon surveyors and a brand new piece of equipment that we'd recently acquired known as the Amberg Rail Trolley Solution. So it was about 5 kilometres of data that we had to capture in 1 weekend possession. And that's quite a feat to do, and doing it conventionally, we probably wouldn't have got it done. So we went up to the mountains, we sent 4 surveyors, 3 total stations in the Amberg Rail Trolley. We went up to the mountains for a long weekend, and we managed to get it all done. And furthermore as well, it was a great showcase to our client of exactly what we could do here at Aurecon, what our innovation brings to it, and what this piece of equipment can do for them. One of the biggest steps out there was that out there in the tunnels, in the field, we were able to display the kinematic envelope of the train on the screen in front of the client, and they could see exactly the level of infringement that was occurring. And we had so many people gathered around this equipment, in awe at what it could exactly do. but yeah, that was that part. So we took it all back to Sydney. We processed our data. We came up with fantastic three-dimensional point clouds, which is really good for visualization. We were able to run the kinematic envelope of the train through there, identify all the infringements, and we produced some great outputs, such as heat maps, which showed the like a color variation of the level of infringement that occurred. One of the deliverables was that we had to produce 1 meter cross sections through all of the tunnels. Now, 1 meter through 5 kilometers is quite a lot of work, but using this system and this technology, we were able to automate that procedure as well. The client was really happy with our work, really happy with the technology, and it led on then as well that we then got our survey team in there for the construction support side of it as well. So from one contract led into the next. And it's been such a success so far that the client is looking for us to get a second one. So yeah, job well done all around there, I think. So I think that's my my nervous story over, and I'll pass it on to the next poor victim.
Hi everyone, Josh Nelson. Just imagine if you had to design kilometres of above ground services in a rail corridor with only just a high-level survey, a 2-kilometre site walk that you completed weeks ago, and photos from that walk when you probably just missed that thing you really needed to see. Well, that's exactly how we design rail feeder projects only just 1 year ago. As mentioned, we get a DSS, which is a site survey from Sydney Trains, which just has indicative line styles and service indications. And basically we'd use photos and a site walk and measurements from things we've remembered to take, and we'd map out our route. The limitations with this is that it's really largely inaccurate. So we found a lot of the time we'd be getting a lot of RFIs from the construction team asking us what are we doing, because it doesn't work. So it's inside a rail corridor, so the biggest issue is you can't go back in there really quickly. You have to wait for possessions and lots of things like that, photos. So our first way of fixing this issue was aligning with Aurecon's two of Aurecon's pillars, digital and innovation, utilising point cloud technology like Hugh just mentioned. So this technology allows us to rapidly capture the site information up to kilometres at a time, quite quickly. This site that we were working on took 1 week of field capturing. So that's quite quick for about 2.5 kilometres of site, and that's capturing everything. So topography, services, buildings, overhead lines, everything. So we first tried to bring this point cloud into our design software and found, because of the file size, it's about 30 gigabytes, it was really hard. It slowed down all our programs and we weren't able to cut sections very well. You couldn't model kind of services to the sections and very accurately, and yeah, they had massive limitations. So the final solution was to get this digitised. We work with overseas offshoring partners. A team of modelers can then turn that point cloud into solid 3D meshes and surfaces. The advantage of this is it allows you to bring your design into the real world models. You can bring your services up next to buildings, check for clashes, check for clearances to existing services, measure from, cut sections, all in one collaborative environment. So obviously the initial reason we wanted to use this technology is to increase our level of accuracy. It allows us, as I said, to check for clashes and things like that, but it also allows us to check constructability, if we've got enough room to install what we've said we're going to install, and basically find issues before the construction team gets out to site, saving tons of RFIs, rework, to and forth, and also making Aurecon look stupid. Saving us to look stupid. Yeah, another unique outcome was the ability to actually run constructability and design workshops with the constructor and the client in the room, working live in the model, moving things, checking for clashes, and just basically locking down the design in preliminary phase rather than getting all the way to construction, then finding all these issues, going all the way back and forth, lots and lots of rework. It allows all of the parties to visualize the design really well. As you can see on the pictures, it's quite a detailed thing. So that took the modelers overseas about 2 weeks. So it's well worth it to turn that point cloud technology into something really usable. A lot of the other things, we've had the clients mention that it was far better than working through drawings in a constructability meeting. It's as I said, much easier to cut a section live and show them why it doesn't work behind that building, or show them clearances to certain services. And it also allows us to get accurate bill of materials, lengths of conduits and cables, and basically allows us to be future ready for when the client is requesting some asset owner information, so that we can put tagging and kind of other smart systems attached to it. And the next stage is to then bring in automation and automatic detailing, tagging of the equipment, etc. Thank you.
It seems to be a rail theme, so I'm going to be talking about Central Station today. If you're not aware of the project, it's in the order of $1 billion railway station in the middle of Sydney, and I equate it to open heart surgery. The difference being every man, dog and their child are in the operating theatre with you, talking about what you're doing, looking over your shoulder and commenting, maybe you could be doing it a bit better. So I do put this picture up because every time I think of stakeholders, it's all I can think of. But this is an absolute client piece. What we're doing at Central is taking apart the most precious jewel within the Sydney Trains network, and we're inserting a 200 metre long, 35 metre deep box in the heart of a live operating station. Before you can do anything, you need to get the existing services out the way. You need to manage the people, manage the processes, manage the stakeholders. There's been a huge amount of effort by all of the team to make sure that we can touch point with the hundreds of Sydney Train stakeholders, technical, customer service, and all the rest to manage it. So the one story I'm going to talk about today represents maybe a fraction of the work that we're doing out there, but it's a real example of the piece of work that we're doing to take our client along the journey. So Central Station is actually being built below platforms 12, 13, 14 and 15 at Central Station. So in order to do any of that, we actually have to demolish 3 of those platforms and hand 1 of them back, because although we're taking 4 platforms out of action, 1 needs to be operational the entire time during construction. The initial attempt of programming construction sequencing by the client represented roughly 9 months and 13 weekend possessions to take 1 platform out of action. So in a 3.5-year construction program, more than 6 months was waiting for a third of the box to be given to us because we couldn't take the rail out of action. So there's obvious reasons. It's an operating train station. They actually like having passengers at their train station, and trains actually need to arrive. So all reasonably good and valid reasons to want a platform in the middle of operating station. But we really had to take the customer on a journey of understanding what we wanted to do and why we wanted to do it. So by sitting down with all of the stakeholders and actually going through customer-centered design, we understand what they wanted. They wanted an operational rail network. They wanted that available 24/7, but they didn't actually need that. They wanted that available 24/7 when they really needed it. So we had to go through a process of understanding when could they not deal with it. Okay, you can miss 1 platform for a month. Okay, not 2 months, not 3 weeks, okay, a month. So it was a process of taking the client on a journey of understanding what they really needed or what they didn't need, and then actually taking them on the process and proving that you could do something that was initially meant to take 6 to 7 months and do it in 30 days. So although that sounds relatively achievable, that's in excess of 62 piles, ripping up an existing platform, surveying, swapping out 6 overhead masts and building a brand new platform in a very short Christmas shutdown period. So what we actually have to do is take them through the whole process, digitally sequence it, show them the program impact, the cost impact, the customer impact, the pedestrian modelling impact. And by taking them along this journey through a number of months, we ended up saving 6 months in a construction program and probably a fair few $1 million that our client will never tell us about. Because as opposed to handing the platform back every single weekend and bringing the piling rig back over 6 months, we got the piling done in 30 days. So part of that was about understanding what our client really wanted. Part of that was about understanding how we could do it differently. And part of that was proving we could do it. So each one of those really required us to understand and go into depth and give them the confidence of how we would do that. So the key points for us in terms of what we were doing was around the innovation piece. So by using a modular construction and as Langer calls it, DFMA, Design for Modular Assembly, we managed to build the platform, which is 180 metres long, in roughly 23 segments that were craned in and managed directly on site. Every single light, cable and everything else was prefabbed, so all that was needed to be done was the prefabrication of cabling. Every single lift, sequence and plank was modelled and time-stamped in a model, so we took them through what happened hour by hour over the 30 days. There was also a fair amount in evidence. Sydney Trains just didn't believe that it could be done. And there's only so much you can convince someone of something if you don't have case studies. So using the Novarail brand that we've got within brownfield environments, the Langer Heuerl brand and the Oricon brand and the individual designers, we managed to convince them that we had a solution and they should trust us and come along the journey. And they were nervous, very nervous, but we actually got there and convinced them, and they were actually amazed that you could hand over the platform in such a short period of time, fully commission it, and get the product and cut 6 months and millions of dollars out of it. So we kept all our stakeholders relatively happy. Thank you.
So, opening up for questions. Are there any questions? Ashley.
For Jason, I guess question for Jason. In the 30 days, what contingency did you have? And did you get there on time?
A couple of hours, and yes. Yeah, we had a walk with a client around New Year's Day. They didn't think we'd get there. About a day before handover, they still didn't think we'd get there, and on the day it was there. So it was tight.
Was there contingency in the program?
Not a lot. Yeah.
Not a lot of contingency. Well executed plan, clearly.
Because a lot of people here aren't rail people, so I'm explaining what the envelope is. And also, I know what it is, but also when you went through the tunnel, can you mention the kind of obstructions you found and the level of detail you got to? Because that's part of the process.
So the kinematic envelope is the shape of the train. It's modelled for a whole different bunch of aspects, such as the pitch and roll and bounce of the train. So you take the standard shape of the train and you kind of rock it from side to side. You go for like track tolerances and things like that. And you end up with a much wider shape of the train, but it's got a lot of contingency in there as well. On top of that then there's also an extra, I should probably hold that up as well. There's also an extra buffer zone around the train too. Normally that buffer zone is about plus 200 millimetres, but because the tunnels are a World Heritage listed site, we got a special concession to reduce that size down to an extra 100 mil, or down to just plus 100 mil.
Accuracy of the survey?
Well, and that was the one of the biggest aspects was that when we first got the data from the client, the point cloud data wasn't accurate enough, and then to have total confidence in the job that we were going to do, who's better to do it than Oricon ourselves? So we went out, we captured it again, and we had, not to get too technical, but we, in relation to the kinematic envelope of the train and the accuracy of the point cloud data, we reckon there was probably about 10 millimetres there. So we actually extended our buffer zone to plus 110 just as an extra safety feature. In terms of what we encountered in the tunnels, the vast majority of it was actually the tunnel walls. We had a couple of other obstructions such as lights, some GST, some galvanized steel troughing. But other than that, that was about it.
No wildlife.
It was only what's known as hard obstruction. So anything that was temporary and could or would move out of the way, we were luckily able to disregard that.
Very good. Okay, will you join with me in thanking our three speakers? We do have something for them. Laura is coming up with those. As a token of appreciation for putting your hand up. If you have a story out there, this is the plug at the end, and you would like to come up and share your story, all it's got to have is a bit of a story, a problem, how we've used the strategy to implement a solution, and hopefully a positive outcome, but not always. If we've learned something, that's a good story to tell too. So join me in thanking our team. Thanks. See you next time.